watch that recording. Okay. So for the moment distribution method, we are using for indeterminate structure. So that can be beam, that can be frame, like the way we saw the indeterminate structure and we solve it. But previously we used different method. This time we are going to use another method that called moment distribution method. So moment distribution method, that one basically this person developed this method, Hardy Cross. It's a he or she, I have no idea, but he or she, that person, established the moment distribution method. And for moment distribution method, it's like you can understand from the word that you don't need to use the general way to calculate the moment. It there will be, suppose for here we have hinge, for there will be some distribution factor we have to compute, and then it will be distributed into two bars. Okay, so first thing, let's use this color. So suppose if we have beam like this, then what we have to do, because it's already indeterminate structure because it has fixed end, then extra we have two roller support, that one we don't need. So what we will do that we need to imagine the temporary restraint, that one we apply, and then we will think that that has a chance to freely rotate. And to prevent freely rotation of that structure, what we need to do, we will introduce roller here. Okay. Then we need to show that how we will show the distribution factor. So we will come back to this point later when we'll started doing the math after that.
Is there any way that you could post these notes to Blackboard so we can download them to have access to them while you're going over
You
them?
want me to down upload now?
Yeah, that would be great, just so we can annotate them along with you while you're
Oh,
teaching.
okay, okay, okay. Because I was thinking to upload it later, but I can upload now. Just give me few minutes. Yeah,
Okay, thank you.
for 1 minute. Class lecture. Hmm. This one week 11. Sorry, week 12 or 11?
Week 11 or 12.
12. Yeah, week 12. Oh, need to upload it here. Oh. Just 1 minute. Oh.
My kids, it was the remote control. I loved the remote control.
Yeah.
What happened?
Thanks for a minute.
Like you.
Honey. Oh yeah.
You're gonna be a smart baby.
You guys can mute yourself. Okay, it's uploaded. Just try you are able to see it or not. Okay. Mina, can you just try it that you are able to download it or not?
Yes, it's on Blackboard. I can see
Okay.
it.
Okay. So after end of my class lecture, I will upload it later again. So, okay. I just started. Is there anyone in the meeting room? No. No. Done. So here we have one continuous beam. So it's from your book. I just copied. So here we have beam that A and C, it has fixed end. One vertical load applied downward. Distance is given for each, and also here we have roller support. So it's indeterminate structure, right? Because it's not statistically determinate and you are not able to solve using the assumption of fx, fy, and moment. So first thing what we have to do, that we need to compute their stiffness. So stiffness is given here, that one is I, moment of inertia divided by length. So if it's not written in any math, so stiffness you need to compute Ki divided by L. Make sense? Okay. So then you have stiffness for AB bar, and then also you can compute stiffness for BC bar. So just did. And then you need to combine them because we need combined stiffness for computing the moment distribution factor. So we have stiffness, total stiffness, and you just add it. Okay. And what will be the distribution factor? Distribution factor equation equal to df. df means distribution factor equal to the stiffness for the specific bar, the bar you are going to compute divided by total. Stiffness for the specific bar is, let's say here AB bar divided by total. I don't want to write here, it's written. AB bar divided by total. K total. Oh, OMG. It's so difficult to write like this. Total. So you compute the distribution factor for AB and BC bar. So they wrote BA, you can write AB, it doesn't matter. But the thing is that it's always better to start from the end, because here we will write that distribution factor value. So we are computing for this point, that how that moment, whatever we are going to calculate, how it distribute to the another point, another sub. So we get the distribution factor for AB bar at point B, 1/3. Then compute distribution factor. We know stiffness for the KB bar divided by total stiffness of the beam. Do that, you get the distribution factor for B point in BC bar section, 2/3. And now again we need this table. We need table that fixed end moment. That table I also attach, I think, where, yes, here I attach that full table. So you can see that fixed end, from the fixed end moment table, case number A match with our system. So use that one. You don't need to compute moment by yourself. You can use this PL by 8 and just what? Okay. You want to say something? So just compute the fixed end moment the way you compute last class. Do that. Last week class, week 11. Then we are going to use those value, how it distributed to the other points. So we already get to know, and we know that distribution factor. We just, again, you need to draw the beam. It's better to draw again another one time and then write distribution factor. So they wrote on the top of the beam, you can write the below beam at near B point that it's 1/3 and this one is 2/3. And then you know if EM, you just compute few minutes ago, minus 30 plus 30, just write that thing. And here we have nothing because it was free, there was no load is applied. Remember that if there is no load applied, FEM equal to 0. So we use the same concept what we learned before. So first thing what we have to do, that we need to distribute it. So here 1/3. So here we have from FEM we get 30 plus 30. But when you were started distributing your moment, so whatever the sign for FEM, when you will started distributing the moment, it will be the opposite sign. So if it's plus, then multiply with distribution factor, then use the opposite sign of the FEM moment. So here 1/3 of 30, it's so easy math, minus 10. 10 and we are going to use opposite sign, so minus 10. For A point, it will be distributed half of whatever we just compute now. So it's 10, half of 10 is minus 5. Make sense? And then for this one, 2/3, if you do the 2/3, you will get 20. And also it's the minus because we are going to use the opposite sign. Half. So in the opposite support, it will divided by half of the compute distribution moment. So use half minus 10. It's already less than 0. So we don't need to distribute again. What if we have their positive some values, a positive moment? Then again we need to distribute those moment again. But here it's already too much lowest value compared to 0, since it's less than 0. So we don't need to distribute again. So we are going to stop that one. And then what you are doing here, just summation of this point. 30, summation of these two. 30 minus 5, 35. And then here, 30, use this color, 30, plus 30 minus 10 plus 20. Here we have only minus 20. Good. Here we have minus 10. That's our moment. So look at the beauty of this math, that you don't need to do any complicated calculation. Just use the distribution factor and compute distribution factor from the stiffness, then started distributing your moment. If you know FEM, you can distribute that things based on the distribution factor. And now again the common things, you have to draw free body diagram, draw FBD, free body diagram. Ignore those sounds. Yeah, in the downtown, it's horrible. So here we have minus 30 and plus 20 for AB. Then for BC here, minus 20 minus 10. Write that, please. And now again, in the last class, I told you, last class, last to last class, that you don't need to do take a moment and then compute their force. What you can do, that you know here, minus 35 for this one, 15 into 8. Here I have positive 20. Do that thing. So you get 6.56 for this point. It's a, I compute for B, BY, let's say BY 6.56. Keep. Now, again, I don't need to use anything like summation of FY. I don't need to write. You can use your calculator. 15 negative 6.56. If upward, just do the math. You will get 8.44. Make sense? Yes, no? If no one
Just
can, yeah. Okay.
one quick question, going back up to the distribution table, maybe I missed it, but what does the COM stand for after the distributed end moment?
Oh, okay. So this one, so it's a carryover. So they are like after distributing load, how much moment carry over that another point. So they are just naming in a different, means you can say that different name of that moment.
Okay, and once the distributed end moment
Yes,
is determined, you always just divide it by half if you're going between 2 points to get the
yes,
carryover
yes.
moment?
It's always
Okay,
the half. It's always the half. So here
okay,
for this, so near the support, whatever distribution you have, like distribution factor you have, and then once you get that things from this one, it will be half.
okay, thank you.
Yeah. Okay, so we already get the force for vertical force for A and B, and then for BC bar, uh 20 minus 20 minus 10 minus 3.75. Make sense? So it's downward. And then if it's downward minus 3.75, here it will be upward 3.75. We have all the forces for drawing the shear force diagram. So I am expecting you already know how to draw the shear force diagram. So we have 8.44 upward, then here. So it's this 15 actually for this one here, going down. Then again, you get this value. Then for this one, going up. Then again this one. Then at the end, it's 0. And for, if you know your shear force diagram has here 0, then how you will get the moment diagram? You need to start from the moment you have external moment, that one 35 here, here 10, and rest of them it's from your shear force diagram, your area of the shear force diagram. So minus 35 plus area of this one, then you get something like that, then minus from here, minus of this area, then you get this, then plus of this one, you get 10, then you have minus 10. Done. Make sense? Okay. So here I add that one, that you will not forget that you have fixed end moment. Okay. Yeah. So here we are going to show another. That's why I was writing here. So first you need to write fixed end moment based on the structure. It fixed end moment equation can be changed. Equation is not correct word, that moment, yes, moment equation will be changed based on the structure. Then you need to find the unbalanced moment at the joint, and after that you will compute the distribution factor. After computing the distribution factor, then for the balancing you just need to distribute it, carry over half to the far end. So C means carry, O means over, A means moment, carry over moment. Carry O means over and aim for moment. Okay. Moment. Wow. Okay, now we are going to show another math. This one, say, beam just with the different load. Here we have vertical load, that point load downward, and then also we have uniform distributed load here for only for BC part. Stiffness, if I'm not giving you the stiffness value, but still you know that how to compute the stiffness for each part, I divided by length of that bar. So here it shows because it's the example from the book, so there was everything there. So KAB stiffness, KBC stiffness, KCD stiffness, you have to compute it. Okay, and for the distribution factor, how what you will do for suppose you have B joint and C joint. So for B joint, you need to use AB and BC bar. For C joint, you need to use BC and CD bar. Now we have total 3 bar, so you need to pay more attention. When it's 2 bar, means beam has 2 part, it's so easy. But for 3, it's also easy, just need to be more careful for that. So you already know how to compute the stiffness. Okay, you have that thing. You need to sum of that 2 bar stiffness because we are dealing with that 2 bar now for joint B. Do that, you will get distribution factor for BA and BC, half of. And again, for C joint, again you have stiffness, and then you need to sum of that BC and CD stiffness, then compute the distribution factor for BC. So here we will have some distribution, and for CD also the same, this point and this point. So we just do that, and then we are going to use the table because here, look at this one, here we have that one match with the case number A, and for this one, for the uniform distributed load, that things. So we use the table and compute fixed end moment for each bar, same like the previous lecture. And for FEM for CD bar, again it's 0 because there is nothing. No load is external load applied, so it's not matched with our table. If no external load, that means FEM is 0. Okay. So yesterday when I was making this one, so I already wrote because it takes too much time to writing everything. But you don't need to write for me during the exam or during the class assignment. So here we already compute distribution factor half, and for this point 1/3, this point 2/3. So wrote those things. Also, FEM we just get from the calculation, we just calculated, write those things, and here they didn't wrote anything, that means it's 0. So if you are getting confused, you can write, instead of blank it, you can write 0, whatever you prefer. So first thing what we have to do, that we need to start distributing. So here that 24, how we get 24 value? So we need to sum that 48 and minus 96 divided by 2. Why divided by 2? It is half distribution factor. It's 24. And this 24 will carry over moment will be for another point is half of that. So it's 12. Now come to this one. So if it's 24, obviously this one also 24, right? So if you notice that 48 minus 96 in the calculation by itself minus 24. But if you remember just few minutes ago, I said that whatever you will get from here, that value we are going to use the opposite sign. That's the change. So here also 24 we just compute from here and then it will be carry over 12. And now for we just deal with joint B. And now we carry over done. And what we will do, we have now focus on in the joint C. So for the joint C, here we have 96, here carry over 12, 96 plus 12 and multiply with the distribution factor. Did you see that I did exactly? I showed the calculation that and then you can, when you will go back to home, you can do it by yourself. But again, those red marks you don't need to show me. So it's a minus 72. And now it's carry over half, 36. Make sense? Okay. So as you get that here 108, 96 plus 12, and then here 1/3. So it's 36. And after that it's half 12. Sorry, half of the 36 is 18. So we get that 18, and for this 18 also it will come to this joint at B. So what is the distribution factor? Half. So 18 into half plus 9 because it was minus plus 9. Here also plus 9 because both joint are same. And now half, half. Make sense? Anyone get confused? Sam, did you get confused? No? You understand? Sam is here?
Yeah, it made sense.
Okay. Okay, so after carryover 4.5, then again we started doing that things. Here I have 2/3 distribution factor minus 3, 1/3 distribution factor minus 1.5, and then here minus 3 it will be carry over minus half. So half will be the 1.5 minus this one we just compute few minutes ago, carry over half. Okay, done. And then what they did, this one again for joint B, it's a B, yeah. Joint B, we are doing the carryover half. So for this math, it's so easy because there is half half. So we don't need to compute again and again. But what if there is different? Then we need to compute. So it's the same value for the half of that distribution factor, multiply with distribution factor, you get 0.38, and then it carry over half moment at the end of the you started from B, you have moment here, it will be carry over half to another support. Same thing happened for this one, it carry over half. Okay, and then same thing for 0.2, you did 1/3 minus 2/3 this. And look at this one. For this one, we are not doing anything because it's already minus. So it's smallest value. So we are not able to do anything. So we are going to leave it. And also for joint C, we get lowest value. So we are done. We don't need to distribute again. So we'll get more minus, more negative. We don't need. So we are going to stop once you will get something like that. And the final moment, this one is like the summation of 48 plus minus 48 plus 12 plus 4.5 plus 0.2 to minus 31.3. Again, you don't need to show that things. If your answer is correct, then me and my TA will think that you already know that things. The summation of all the moment you have, just do the summation, you will get 81.38. Summation of all the moment you have, you will get minus 81.38. Then again, summation of all the moment you have, you will get 75.13. Same for this one, summation of all the moment for C, minus 75.13. Did you notice that those are same, just opposite sign? Because it's the same structure. So whatever moment we'll get for this point, so it will be the same. If it's not the same value, that means you did something wrong. You need to go back and check your calculation. And here we have additional moment. Just for this one, sum of these two, you get this, because obviously for fixed end there will be some moment. Okay, so we have everything in, and now what we have to do, we need to draw shear force and moment diagram. So what we can do here, I was whatever I explained, that things written everything. Then what if you forgot, then you can just check. It's, I don't need to repeat that things again. It's just showing all the step like a baby step. Yep. Where is the shear force diagram? Oh, here we don't need to, I didn't show the shear force diagram, but if it's written, where is that question? So if you have moment, then again you can draw free body diagram like the previous one and just compute their force and draw shear force diagram and bending moment. Make sense? So for this example, basically in the book, they are not showing that things. Maybe in the exam, if it's because it's already too much long a math, where it is. You just need to show up to this because it's too much long and it will take some time. So if it's has three A, B, B, C, and C, D like this, then maybe I'm not going to ask you for draw shear force and bending moment diagram. If it's small, only the previous one, then I'm going to ask. So you just need to compute from here, stiffness, then what will be the distribution factor, fixed end moment, use the table, and then you are good to go. Okay, so it's this one for you guys. You can check. So what if that there is some error, like a fabrication error or temperature, due to temperature, there will be some error in the structure. Then we need to do some more modification for the calculation. And here, oh, here I forgot that for practice at home, example 11.3, it's the same like 11.2. So you can practice at home if you want. So let's see for who joined now. Here we have the fixed support at A. That one is accidentally constructed incorrectly. And because of incorrect construction, it has slope 0.002. And this is fabrication error because those people constructing the building, there can be some error. So you have to consider that one and fix it. So it's saying that it's a counterclockwise, okay, that vertical axis through A it's everything is given. The support C is accidentally constructed 1.5 inch below its intended position. Yeah. So they did horrible job for constructing the beam. So now what we have to do to compute their reaction, and let's see how to do that. Okay. So what we have to do, we are going to use that general moment equation from the previous class. Remember that equation, that 2ei by L, this one we are saying 2 theta A, then theta B minus 3 psi and Fn for AB part. So here we have, like, if we have fixed end, normally we consider that theta A equal to 0, but here it's already given that it's 0.002 radian. So we need to consider that one, and it's anti-clockwise. Sorry. So that one we need to consider. Theta B, there is no theta B. That one is 0 because there is no rotation happen. That's why it's 0. And psi AB for AB bar equal to 0. There is no nothing happen here. That's why psi is 0. But for BC bar, look at that. What they said, this support at C is accidentally constructed 1.5 inch below its intended position. So now what we have to do, we have some displacement because of that. And if you remember this psi equation, that one is the displacement divided by h, means whatever distance of that specific part. So we are going to use this equation and this equation, the general equation. This is general equation, general moment equation, to compute the moment for this specific structure. Okay. So here we started AB. So 2EI by L, they just wrote the E and I L values. 2 theta A, we have theta A's values here. Theta B equal to 0, so they didn't wrote anything. 3 psi is 0, so that we get this one. And as there is no external load applied, so FEM equal to 0. Now again we need to compute for BA bar. Okay, so BA bar, you remember that things when we are writing the general equation. So it's saying that we started from the general equation 2 theta B right now, then plus theta A, then minus 3 psi. So here we have only theta A value, we just wrote get MBA, moment at BA. Like exactly the same like the previous class. Okay. And after that, we already know theta B equal to 0, theta C equal to 0, but psi, we just use this equation and then compute it. And if you ask me why it's 12, it's because it's 25 feet, I guess. Yeah, 25 feet, convert into inch. The thing I said few minutes ago, they wrote in the book that things. And now again, you need to compute, use the general equation we have, compute moment for BC and CB. You just compute it and then you get this one. So we have already moment. And now what we have to do, we need to compute the distribution factor. So we compute the distribution factor for joint B. So what was the equation? I divided by length for that specific part. So here I value is given 300 divided by length of the AB bar, computed. So for the BC, you have this one, then compute it. And what else? Okay, nothing. And then summation of distribution factor you get for AB, for B joint, and for another section of that beam for B joint you get this value 0.375. Okay, now you are writing those things that I have distribution factor 0.625 here, B here 0.375, and here as it was initially it was roller support. Okay, as initially it was roller support, we consider that distribution factor is here 1. So we already compute fixed end moment. Just write that things in the first row, and then we will start distributing it. So here we have 1. So 1 multiply this one, same value, just sign opposite sign, and then it carry over half. So in the previous math, if you remember, we didn't start from this at the end, because at the end there was nothing, it was 0. But here we have some distribution factor. So we need to consider that things. If it's roller, then we will consider that there is no distribution factor, because there will be at the end there will be some moment. But here there will be no moment, so that's why it's 1. So we did that things, it's carry over half, 36.3. And we have these 2 we get from fixed end moment. Sum of these 3, you will get 48.3. And this is 0. Okay, so I was writing and it's getting triangle shape 0. So 48.3 multiply with the distribution factor you have, you will get this 18.11. And now for this one, distribution factor, summation of this 48.3, distribution factor 0.625, you will get 30.2. It's carry over half. So did you notice that in the previous math, it was for B joint, it was the same distribution factor. So we are using the same value. That time I was saying that what if there will be different? If it's different, we are going to use this type of things. And now here, look at this one, that the summation of this is 0, final moment. As it's 0, it's already, if you remember that I said, when it comes to near to 0, then or less than 0, then we need to stop distributing the moment. So here we already get in 1, it's 0, so there is no point to do anything, and we are not able to do anything because we have only 1 this positive. Then summation of for B joint minus 70.5, 36.3 plus 18.11, you will get minus. Also, it's less than 0. So it's too much low value for the moment for that. Here, we'll obviously will get the same value 18.09, but opposite sign. Just check this, sum these two value, moment, you will get 18.09. So it's good that you already receive get that same value. If it's not, then you need to again go back and check, maybe you did something wrong with your calculating the distribution factor. That one value is maybe you did something wrong, or maybe sometimes students, what they are doing mistakes for this math, they are just sum these two and started distributing for this B point, but it's not correct. So it already have carryover something, you need to consider that one. So they forgot these carryover things. Okay, so again here the summation of these two moments minus 9.1. So we have everything. Now I think again it shows all the stuff. Okay, so we just wrote all those values, those moment we receive, we get from the final moment. We just uh, write the free body diagram. And again, now I'm expecting that you know how to compute that force, that this moment, and divided by the distance of A. You will get force for this. And now there is nothing, so whatever force you will have here, it will be opposite sign downward. And you already compute for this one, so opposite of this, it will be the opposite sign but same value. So if it's 0.45 here, okay, that's good. And now for this one, we will start from here for BC part. Here we can take a moment, and moment divided by distance, you will get this one. If you get RB here, downward, for this one, it will be upward. If it's upward here, it downward for this joint, the same value. Remember that things we just did yesterday, not yesterday, last Tuesday class. And then you can take summation of Fy and you will get this value for B. So now you know all the forces, all the moment. And now just draw the shear force diagram. So I'm expecting you know how to draw shear force diagram. So 0.45 downward, then it goes up, and for this one you have the values and then get something. You'll get the 0. And then what will be the moment? Moment will be you started from the external moment you have, and then the area of that shear force, consider that one. Then also it's minus, but here we at the end for this positive shear area, it will come to 0. Make sense? Okay. We can take 5 minutes break, and meanwhile you can go through the lecture, or you can just sit.
Do you mind just going back up to the distribution factors at joint B and C?
Okay. For this one?
Just a little bit higher, like when we were computing them.
Mm-hmm.
I'm just wondering where the 3/4 for KBC is coming from, because if it's I over L, wouldn't it just be the 300 over 25 for KBC?
Okay, let me check the. What's the question number?
For KBC, if you scroll down, when we're actually computing or calculating the distribution factors like KAB and KBC, in that third box right there,
Yeah.
it's I over L for KAB, but then it's 3/4 times I over L for KBC. I'm just wondering where the 3/4 comes from.
So there, I should add that table here. I forgot to add. Um, okay. So if we have, so if I go back to here. So for this one, look at this, that when we are saying that not distribution factor, that is stiffness. For stiffness, we are computing that one with when we have that roller support and roller support with the fixed end. So if we have the roller support with fixed end, then we can use this straightforward I divided by L. But if we go back to the next one, so there is roller support with the roller support. So the equation is different.
Okay.
Yeah, so I should I need to add that equation. Oh yeah, I will add that equation later and upload it.
Okay.
Yeah.
Sounds
I,
good.
I
Thank you.
just thank you for asking. I forgot that. Yeah.
Yeah.
Okay, we can take 5 minutes break. Yeah, and I need to drink some coffee. Meanwhile, you guys can just because you can say your just present or something, just one word. Then I can get to know your name, so I can share your name to my with my team for attendance. I was expecting that at least today there will be lots of students because I received email that because of snowstorm, student will not be able to attend. That's why I today for the first time did online, but again the same thing. Yeah. We can start. But first question I have, did you guys go through the review class? Anyone? No one? That means no one did.
What was that?
Did anyone go through the review class?
I did.
You did? Well, you did, but what's your name? I forgot. I cannot see.
Milan.
What?
Milan.
Okay. Oh, you want to hide your name?
Yeah.
Okay. Okay, never mind. Yep. Yeah, just please go through the review class. I know you guys are so busy, but it's important. Okay, we can start now. This one. Yep. Whew. Another math. So it's say that we have frame A, B, B, C, I value is given. Now it's a fabricated 1.92 inch too long for AB bar. And because of that, there will be moment created in the frame. So you need to compute it based on the moment distribution method. It's record started. Yeah, hopefully yes. So what you have to do again the same type of stuff. You know that here theta b equal to 0, theta c equal to 0, and because of this one fabrication there will be psi value. And what is the psi? Psi equal to deflection divided by L. So we just did that things. And then for both, but there is no external load is applied. So that means that equal FEM, there is no FEM. So FEM equal to 0. And it's also written that no load applied. So everything is written on the book, just you need to know some tricks to solve it. And now again we are going to use the general equation. So we have general equation, that one is m equal to, let's say for the AB bar. Oh, for BC, so let's write BC. Otherwise, you will say something. 2EI by L. So I started from B, so 2 theta B plus theta C, and it goes then minus 3 psi BC BC FEM equal to 0. And for only for this math, the good thing is about that theta b and theta c equal to 0. This part is 0. This part is 0. Same for if you write the equation for CB. That's why they wrote MBC and MCE equal to only, there is only this term we need. So you don't need to write the full equation. If you are capable enough to write this equation, you can do that, or you can just write one time this equation and you will be able to understand one time, then write that things and write that MBC equal to MCB. So you get the moment. Okay, we are going to take that moment for distribution factor, those stuff. And here distribution factor. Wow, I didn't add that things. Whew. So again, you can compute distribution the factor same like the way we did before. And then I will add at the end of the class. Then you will not get confused. Did I add or something? Yes. Yeah, I add that things. Distribution factor. Okay. So we get the distribution factor the same way we get the previous one. We wrote the equation, get the distribution factor summation of the stiffness and the stiffness of the bar. From that, get distribution factor. And now we have to start distribute this moment for BC. Look at that one. So they want to confuse you a little bit. That's why they wrote lots of stuff. So you start from minus 4.82. Minus 4.8, minus 482.13. 400, this one, multiply with 2/3, then you get this value. Okay? Makes sense? And then this one, this moment, FEM moment, multiply with 1/3. You will get that one. And we are using opposite sign. So here, the moment is same, right? So don't get confused with these two. Insert. Shit. Don't get confused with those values. So we have minus 4 here and it distributed 2/3. So here we get minus 321.42. And now this is the frame. So it's little bit different from the beam. It's not the half over carry because here we already get the negative values. So if you remember that the purpose of using the distribution factor, that it will minimize our calculation, and also if we are getting the smallest moment values for the bar points for each points, then we are going to stop that distribution. So we don't need to carry over that things. For beam, we need to show the carryover stuff. Okay, so we have these two moment we have. Now for this one, we have carryover. This, because we have these things and how we will get this moment. So we are saying out. This one is carryover half. Because there was nothing before. So we need to transfer that half of the moment at that point. That one is A, I guess. Yeah. This one is A bar. A point. Then this is B. And it's C. Okay. So again, we did everything. Just show those moments here. And from the moment, again, you can compute. I showed you how to compute the reaction force just using the moment. So here I showed, look at this one, that we have moment here 80.36, and then here also we have moment. So this one, what we get after carryover, why they wrote, now you'll be able to understand that we have the initial values here, then carryover, after carryover, whatever value, that one is the moment. And we are using that moment divided by length 30. Then you will get 8.04. And again, for this thing, for BC bar, again you are using the moment for this BC bar and just compute the reaction force. And here they are not for the frame. Two way you can show the uh, free body diagram. One, step by step, show A, B, B, C. Here in the book they shows joint together. But if you feel comfortable with the free body diagram we showed in the last class separately, you can do that. So just draw the free body diagram. You have all the moment right now. From the moment you compute the forces, okay, here if it's 8.04 downward, then here it will be upward, obviously, because summation of fy equal to 0, so we don't need to compute again. We get here, we just compute 40.18. Okay, so this one, if it's in x direction in that way, in opposite x direction there will be 40.18 for point A, support A. So you have all the forces, you have all the moment now, then you can draw the moment diagram. They just draw moment diagram, but you need to you know how to draw shear force diagram. So yep, that's it. That's the end of today's class. So today's class, it's getting we finished a little bit early because as you saw that I wrote lots of stuff before, that's why. Yep, I spent significant time yesterday and night as well to complete this one. Do you have any question? No? This time only Nina asked question. What happened with the others? Everyone is sleeping like this way? Or you guys did like this? Sam, did you understand?
Yep.
Oh. Hopefully next time you will be the representative student and teach your friends. So next class, if I ask you something, then you have to answer. Okay? Okay, so and this is the end of today's class. Hopefully you'll able to understand everything. If you're not, then you can ask me, you can send me email if you have any question. And I will add those stiffness equation there, and then I will upload the updated version of the class note. Okay? Okay, so happy Easter break, and please enjoy your break, and do not forget to study your for your exam too. Okay, make sense? Okay. You guys have question? No.
No. Have a good day.
Okay. Okay, same to you. Yeah. Do you have any question, Robert?